Good afternoon, ladies and gentlemen. It's an honor to have the opportunity to address such a distinguished audience. Let me introduce myself. My name is Anita Dewi. I'm here with my friends Zahra Wardani and Hudzaifah. We are from Mechanical Engineering Department. Does anyone know about Plasma Actuator before? During the next 7 minutes, we will talk about it. We have organized this talk in the following way. Definition, how to operate, flow control application, and the last one is conclusion. So what plasma actuators are? Plasma actuators are a type of actuator currently being developed for aerodynamic flow control. Plasma actuators impart force in a similar way to aircraft. Plasma flows control has drawn considerable attention and been used in boundary layer acceleration, airfoil for body turbine blade separation control, axial compressor stability extension, heat transfer, and high-speed jet control. The recent invention of glow discharge plasma actuators by Gross in 2003 that can produce sufficient quantities of glow discharge plasma in the atmosphere pressure air helps to yield an increase in flow control performance. The next part will be delivered by Hudzaifah. To Hudzaifah, please welcome.
Thank you, Anita Dewi, for the time. Hello, everyone. I'm Hudzaifah. I'll continue to explain the topic about plasma actuator. And the topic now is how plasma actuator works. Plasma actuator works by ionizing the part of the air around the hidden electron and converting it into plasma. The actuator work is based on the formation of a low temperature plasma between a pair of symmetrical electrodes by the application of a hedge voltage as the signal at the electrodes. As a result, the air molecules from the air around the electrodes are ionized and are accelerated through the electric field. Actuator with shallow pre-encapsulated electrode induce a greater velocity than the starting casing at the same voltage. As for actuator with deep initial encapsulation electrodes capable of inducing the hedge speed. Next, the topic is flow control application. The first of the flow control application is voltage generator. Plasma actuator can activate the role of voltage generator. The difference between this and traditional voltage generator is that there are no moving mechanical parts or drilling holes on the aerodynamic surface, such as the serpentine geometry plasma actuator on an airplane wing that produces dynamic flow that is useful for controlling flow. In addition, serpentine plasma actuators have been experimentally demonstrated to increase lift, reduce drag, and produce controlling rolling moment when applied to aircraft wing geometries. Next, the second of the flow control application is active noise control. A research team at Toyohashi University of Technology developed a method for reducing aerodynamic noise through plasma. Cavity flow in the gap of high-speed train carriages often emit aerodynamic noise. A plasma actuator inductor flow is applied to suppress this noise by periodically turning off the plasma actuator power. A higher drop in sound pressure level is observed when compared to continuous operation with the same power consumption. Okay, then for the next part of the flow control application will be explained by my friend.
So thank you, Hudzaifah. Hello everyone, my name is Zahra Wardani. Now I will explain to all of you the third is supersonic and hypersonic flow control. Plasma has been introduced to hypersonic flow control. Firstly, plasma could be much easier generated for hypersonic vehicle at high altitude with quite low atmospheric pressure and high surface temperature. Secondly, the classical aerodynamic surface has little actuation for the case. Interest in plasma actuators as active flow control devices is growing rapidly due to their lacks of mechanical parts, like wake and head response frequency. And the last is for flight control. Plasma actuators could be mounted on the airfoil to control flight attitude and thereafter flight trajectory. The cumbersome design and maintenance efforts of mechanical and hydraulic transmission system in a classical rudder can thus be saved. On the other hand, the whole flight control strategy should be reconsidered taking account of characteristics of plasma actuators. And yeah, just a quick recap of our points is plasma actuators are a type of actuators currently being developed for aerodynamic flow control. And plasma actuators operating at the atmospheric condition are promising for flow control mainly for their physical properties. And yeah, everyone, well, that's all from us. And if you have any questions, please don't hesitate to ask.